Hey, it's Mrs. Rubery, and today we're going to look at two-step equations. So you're just going to solve them the same way, where we need to isolate the variable, get it by itself, and see what it's worth. So to do that, if it's a two-step equation like this one, we first need to get rid of the constant. And in this problem, 4x minus 7 equals 37. The constant is the negative 7. To get rid of a negative 7, we need to add 7 to both sides. So we use inverse operations. And that's going to leave us with a 4x equals 44, which looks a lot like what we're used to in a one-step. Now that we're down to 4x equals 44, to isolate that x, they're inverse operations to divide both sides by 4, and we get x equals 11. Now the nice thing is we can check our work by substituting back in the 11 for an x and seeing if we get the answer of 37. So to check our work, we're going to use our substitution. We got x equals 11. We're going to put it in for x and use order of operations. So that would be 4 times 11 minus 7 would be 44 minus 7, which indeed is 37. So we know that we've solved the equation correctly and it's balanced. Let's take a look at another one. So in this one, our constant would be the minus 8 or a negative 8. To get rid of it, inverse would be to add 8 to both sides. Be careful of your negatives here. On the left, we'd be left with a negative 15 equals a 3x on the right side of the equation. So now we're down to a one step. To isolate the x, we need to divide both sides by 3. So I'm showing that in this step, which would give us negative 5 is equal to x. Again, we can check that our answer is correct by taking that answer of a negative 5 and substituting it back into the equation. So you can see here on my second line, I substituted in a negative 5 for the x. I followed order of operations on the right side, got a negative 15 minus 8, which is a negative 23. It balances with a negative 23 that I already had. All right, let's take a look at this one. So my constant would be my number that's by itself in the equation, which would be the plus 9. To get rid of a plus 9, I'm going to subtract 9. I need to keep it balanced, so I subtract it from both sides, put my big long equal sign. On the left side, I'm just left with an m divided by 5. And on the right side, 11 minus 9 is equal to 2. So now I'm down to a one-step equation. I have m divided by 5. The inverse of dividing would be multiplying. So I'm going to multiply both sides by 5. I show that in parentheses. On the left, if I divide by 5 and multiply by 5, they cancel out. So I'm just left with m. And on the right side, 2 times 5 is 10. Now let's check our work by substituting. So I'm going to take that 10 that I got for my answer and substitute it back in for m. So I'm going to do that over on the right. 10 divided by 5 plus 9, does that equal 11? 10 divided by 5 is 2 plus 9, and keep solving. 2 plus 9 is equal to 11. 11 balances with 11, therefore I got that one correct. Okay, on this problem, I have 4p minus 3 equals 17. I want to get rid of the constant, so I have a minus 3. So I'm going to add 3 to both sides of my equation to keep it balanced. That gives me a 4p equals 20. 4p means multiplication, so to undo multiplication, I'm going to divide both sides by 4 to isolate the p. And that gives me an answer of p equals 5. To check it, I'm going to replace the p with a 5, substitute, and check that it's equal to 17. So 4 times p, which is 5, minus 3. Does that equal 17? So I'm going to keep solving on the left. 4 times 5 is 20. 20 minus 3 is 17, and 17 does indeed equal 17. So I know I balanced my equation because both sides are equal to each other. Okay, now this problem, there really isn't a constant because n minus 3 is grouped together. Remember that a fraction bar is a grouping symbol. So this fraction bar is grouping n minus 3 as one term. So therefore, to start solving this one, I need to get rid of my denominator 4, which is dividing by 4. So to get rid of division, I can multiply both sides by 4. That's going to cancel out the 4's on the left side, and I'm left with n minus 31 equals 8. And now I can solve it as a one-step equation. N minus 31, the inverse would be adding 31 to both sides, which would give me n is equal to 39. To check it, my substitution check, I'm going to put a 39 in for n. So 39 minus 31 divided by 4, is that going to give me 2? Well, 39 minus 31 is 8. So now I have 8 over 4. 8 over 4 is division, that would be 2. So 2 equals 2, my equation has balance, so check, it is correct. All right, it's your turn to practice.